morning still or good afternoon, I don't know. I came from Israel, so the timetables are changing all the time. So now we're going to talk about defense line system, measurement system, and fast technology for ethylene oxide. And just for the knowledge, I'm here for a company named Atmosfir Optics, but we are part of a group that also run analytical laboratory called ALCAN and AS Research Services, all in air ambient air measurement and analytical measurement, analytical laboratory, all ISO certified, ISO 17025. So a few words about Atmosfir Optics. We are not a manufacturer. We are an integrator or service providers, so we are agnostic to in terms of who manufacture the analyzers. We just want to provide our client the best instrument that suits their needs. Among our scientists, we wrote the US EPA method, if you know the method TO16 or the STM method. If you heard the name Dr. Robert Kagan, actually is the inventor of the monostatic open path system, is part of our scientist team. Our company performed dozens of installations from Australia through Canada, Middle East, and we talked about California and Texas. I think we are the first commercial company that got ISO 17025 using open path technology, meaning using our open path software and services. The results will be accredited worldwide under ISO 17025 accreditation, and I think it's the first commercial company that got it just 2 months ago. And we don't manufacture nothing, but we've got a lot of procedures that are patented all over the world, and we're going to talk about it. So the defense line system, our integration software, actually is can use for open path instrument, and today we're going to talk about mainly the FTIR because it's the most suitable for ethylene oxide. But we're also going to talk about a combination of open path instrument with point monitor. And if you are talking about ethylene oxide, we've got two cheap options that one will be electrochemical sense and the other will be a photoionization detector that is not specific. We're going to talk about it. We either sell the system or just sell our software package that will enhance the quality assurance procedures and the detection limit of any instrumentation. So this is the ISO 17 accreditation, world accreditation, and we are accredited for atmospheric measurement near ground with open path FTIR based on European method. Official or the TO16 long path, open path Fourier transform infrared monitoring of atmospheric gases, and it's any atmospheric gases that got IR signatures. So if we talked before about the HCN, we can do it with this method, and we can do the PTEX, and we can do the ethylene oxide that we are talking about today. About our patents. So the patents is starting for the system design. As I told you before, the monostatic system design was invented in the 90s by Robert Kagan, one of our key scientists. It's a Canadian patent, but everybody uses it today, more than 20 years. And then we wrote a patent about improving the detection limit and the data validity, also all over the world. And it's not for a specific instrument. We can use any instrument, spectral instrument. And then we understand that knowing that we've got high concentration is sometimes creating a greater problem. So we wrote another algorithm that will help you source locate it. And again, it's a patented all over the world how to use a combination of multiple sensor and the wind data. In that slide, we see samples, real-time samples from field data, not laboratory data, of very low detection limit that were unbelievable since we wrote this algorithm. And today we're going to talk about the ethylene oxide that we can measure below 1 ppb detection limit. What you see in those pictures are actually spectral signature. Red is the reference spectra from NIST, and the blue is what we are measuring in the field. And you can see by the similarity that the compound that we say that it's there is there. If you don't have that ability, a lot of false positive and false negatives reported. And if it are related to the talk before me, we don't want to be in a situation like that, we report false positive or false negative. So I think this feature is very important. As results of our equality algorithm for the fence-line system, Bruker chose Atmosfir to implement their fence-line monitoring program. We don't use just the Bruker, but Bruker got world offices all over the world, so they got support all over the world. And it's a reliable and robust instrument that our client can win. So what is the D-fenceline system supposed to give the clients? We want to tell you where something going wrong. Most of the emission we will see in the next few slides are coming from upsets. So you need to monitor 24/7 along lines and not points if you want to capture the emission and the right time that it's happening. Secondly, we want to tell you what is the problem. So using an open path FTIR, we can tell you the ethylene oxide, but we can tell you a lot of other compounds related to that. So let's say if I will find ethylene oxide with ethylene glycol, so now we can know what is the problem. So one instrument can measure tens of compounds simultaneously, and we got clients that measure 60 compounds simultaneously with one instrument. The third question that we want to answer to our clients is where the emission is coming from. And that we will do with triangulate the width. You will see the next few slides. And the basic behind that is, we know that we got a problem, now we want to fix it. For knowing how to fix it, we need to know where it's coming from. So we will give you an answer for this question. And I think the lastly, it will be how much. We know that concentration is just part of the picture. We can have high concentration due to no wind. And then the concentration will accumulate and we will have a high concentration. Or we can have low concentration because of very turbulence or very high wind. So in order to know how big is the problem, we need to quantify also the amount. So why using a system like that? First of all, regulation, it's the easy, and that's how we got most of our clients, regulation or consent decrees, as been told in the first presentation. But we can prove that it will reduce your environmental impact. I think even the most important thing, for sure, when we talk about ethylene oxide, it will contribute to the health and safety. And we would like to say it's also cost effective if you look at the broader picture. If you are talking about ethylene oxide, we are mainly talking about petrochemical industry and sterilizers, so hazardous material holders. So what is the source of the emission? So let's look at it as a petrochemical industry. So if I will ask most of the people, they will tell you that it's coming out of the chimneys, but we know that because we started monitoring the chimneys or the stacks in the 70s or 80s, and then we took down the emission, and now we are left with fugitive emissions, or the main sources are now tank farms, product terminal, equipment failure, human errors, cooling towers, and evaporation pools. And we are not measuring them routinely. Some of them we are measuring with the ELDA project, but between each one of ELDA project, emission can occur. Yesterday, there was a talk with the EPA about ethylene oxide of one of the biggest facilities here in Texas. And then it was declared by the US EPA that more than 50 to 70% of the emission are caused by upsets, meaning that they lost power or something was broken and one of the employees forgot to close a valve. So if we will find those sooner, then we can reduce our emission. And let's say we've got LDAR project every quarter. So every day, if we find it the first day it happened, then we can save 99% of the emission from that valve. So keep in mind that every day that we find it sooner, it's 1% of the emission that we reduced. So if we take it as an average, if we need to do quarterly runs, so implementing technology like open path technology will reduce your emission by 50%. And I think it's good enough motivation to go in that route without regulation. So where should we measure? Again, chemical complex, we can put a lot of point monitors like method 325. As we know, pollution goes with the wind. So if we will put our sensor at point E, what we will do, we will over-report our emission. Because in point I, G, or B, we don't have nothing, but if we are reporting just point E, then we are over-reporting. And the ability to catch the plume, most of the time we will miss the plume, and then we will be underestimated. So point monitor need a source put us in a situation either we are underestimating or overestimating. And we want to report what we are actually emitting. So just for the understanding, open path sometimes is good for the industry. Imagine I will have a point monitor at point E. The concentration can be 100 times the threshold. But if I average the line between D and F, then the concentration can be just twice the threshold. So if you use open path, sometimes it's all the time more representative, but sometimes it's even good for the industry because you average your results. It was adopted by the EPA, and as we saw in the first talk, by California rules, by GD 52 of the EPA, and by Colorado rules, and now by Canadian rules, Thailand rules, and even Saudi Arabia. Open path measurement and D-fenceline dramatically improve the ability to represent your emission when measurement need a source. Point monitors are good when you are in the chimneys or where you are far away from the industry. If you are on the border of the industry, point monitor will not represent your emission. So two things. If you want to know what is your annual emission, you must measure all year round, and that's why you need to measure 24/7. And I think the basic for reducing your emission is finding the problem faster. As I told you before, each day equals to 1% of reduction. So if you wait 3 months for the LDAR to come, you emit 99% more than what you have done if you find it the first day that it happened. So what the TCQ says about ethylene oxide. So let's start with the chemical. So first of all, it's a very volatile compound, meaning we will find it in the gaseous phase. Second thing, you got odor threshold. So you said, we can smell it. But if you read the odor threshold, we are talking about hundreds of ppm. Hundreds of ppm is way above any threshold for ethylene oxide. So if you smell the ethylene oxide, run away because you are much higher than or 100 times higher than the threshold. So it's not a good way to sense ethylene oxide. And another thing that I want to tell about ethylene oxide, it's a very soluble compound. Meaning if you're going to use a point monitor that got long tubing, that ethylene oxide will soluble in a droplet that will be in your tubing, and then you don't know when something is going on and where it's coming from, because after it's soluble in the water, then when it will go out, we can never tell. The second thing that the TCQ wrote about the ethylene oxide, they put chronic health threshold, and it's 2.4 ppb. And it's very low concentration. But if you're going to go to the EPA website, and this is the threshold that they're talking about, and it's based on cancer risk, not of the node measurement. They're talking about 0.001 ppb. And there is no existing technology or official method that can measure that low. So the regulation will not be that low, and it's put a big question mark about this data. Again, from yesterday talk, when the EPA does measurement, they usually use canisters. Method TO15, and put the canister and then analyze it, try to analyze it by GC mass spec. And same group of method got the TO16 that we talk about using an open path analytica, open path technology, or FTIR for measuring gaseous. So it's the same group. Again, TO15 will not go that low because, again, we are talking about very soluble compounds. And if you want to do analysis with canister with very soluble compounds, you got problem. And the same goes with also passive solvent use. We are in the environment, we've got 2 to 3% absolute water. So then how we can analyze it become a problem, and that's why they cannot push the method that low. They maybe can push it around 0.05 ppb, not less. So it's an order of magnitude higher than what the threshold we are talking about. So I want to talk about safety. It's a very explosive compounds. And just a year ago, there was explosion in Spain. 2 people were killed, and the parts of the equipment for the facility were found kilometers away from the facility. And if you're going to put a system on the fence line, maybe you can find the leak before it becomes an explosion, and that will contribute to your health safety, and maybe explosion like that can be avoided. What you see in the picture again is a real field data from Texas that prove that ethylene oxide can be measured below 1 ppb using an open path FTIR. So what is an open path FTIR, and what is the monostatic configuration? This is a Robert patent. But on the one side, we got the FTIR with infrared source and detector. We shine a beam of infrared light into a retroreflector, that mirror that you can see on the side. The energy bends back and to the detector, and now we do the analysis. Two basic rules of spectral analysis. First of all is the Bell-Lambert law that says absorption equal constant multiplied by the concentration and the path length. Because we know to measure the distance between the retroreflector and our FTIR, so the distance or the path, we know what it is. We can measure the absorbance, and now it's easy to get the concentration. It's not that easy. The second rule is that any molecule absorbs light in different region of the spectrum. So there are not two molecules that look the same if you look with high enough resolution and all the spectrum. So this is the strength of the FTIR. One instrument can measure hundreds of compounds simultaneously, or not simultaneously, but with the same one instrument. The problem is if you don't do the analysis correctly, and if you don't take into account all the interferences, then a lot of false positive and a lot of false negative can occur. And a lot of the problem that we find is air-conditioned gases. They absorb light on all the infrared region. And if you didn't put it in the method, and if you don't account for it, then all the compounds will have a bias, positive or false positive readings. So how the analysis goes, and I like this because it's not too complicated. So blue is what we are measuring in the field, and it's superposition of those three compounds: ethyl acetate in red, methanol, and acetone. You can see here that the blue and the red and the blue and the green are the same. But over here, you see that the blue is much higher than the red because it's ethyl acetate plus methanol together, and that's how you can explain all the analysis. So the analysis done with a lot of mathematical algorithm. The basic is classical least square, but there's a lot of quality assurance procedure how to not create a false positive. And if you are talking about ethylene oxide, the story becomes complicated because ethylene oxide absorbs light in where the third butanol, propylene, ethylene, ethanol, ethylene, isopropanol, isobutylene, all of them absorb light in the same region. So if you don't know how to separate those correctly, then you will have a lot of false positive and a lot of false negative, and that's where at least Atmosfir came in. We don't manufacture instrument, we help with the quality assurance of the analysis. Every number that we will report to our client, you can click on the number, then it's open a spectral validation. And it's faster than I did it now. You just click on the number, what you see in red is NIST reference spectra, after subtraction of all the interference, and blue is what we are measuring in the field. And now you can be positive that what you report is correctly, and you didn't do false positive or false negative. So if you are in recommendation to potential client, online spectral validation must be implemented in the store. That is example how ethylene oxide look with our instrument, and this is below 1 ppb detection limit, and the concentration is just 2 ppb, and you can see the similarity between the reference spectra in red and the blue, what we are measuring in the field. When the concentration will go up, and now we are just in 10 ppb, it will look even better. And when we are in 20 ppb, now it looks almost 1 by 1. And when we are in 51 ppb, you cannot tell it. I hope that I succeed on convincing you that we can measure ethylene oxide with open pass FTIR, and that we are based on official method. But now, what we're going to do with the results, we want to fix the problem. So we need to tell you where is the problem, and sometimes there is one chemical plant and the neighbor uses also ethylene oxide, and now you know who to blame. And sometimes now there are people that claim that there is also some kind of global background of ethylene oxide, let's say in around 0.2 ppb. So how can you tell where ethylene oxide come from? So that we do with back triangulation with the wind. So as we told before, air pollution moves with the wind, and we can find high concentration on one segment of the fence. We back triangulate the wind. Then we get a little wind change, and we can find high concentration on different segment of the wind. And then we back triangulate and we tell you the origin. So it's looked very easy, but it's not very easy because sometimes you've got more than one potential source, and sometimes the wind doesn't play right. But this is the basic, and actually it's based on another official method, EPA method, OTM10. We try to do everything easy for our clients, so this is how it will look on the user interface. The brighter the color you see, the higher possibility, we are talking about possibility that the leak is coming from that side. And now, you know you got the leak, you are positive it's the leak, and you know that it's coming from that area. So now it's easy to send our LDAR project people and go and fix the problem, either with sniffers or with OGA cameras. But the idea is we send them the moment we know that something is wrong, and we send them to the area that something is wrong. So we don't need to wait 3 months until they fix the problem. By that, we can reduce actually at least 50% of the emissions. So fence line recommendation configuration should take into account the potential source location. So if we got a source here, or source here, and that area doesn't have ethylene oxide, so we don't need to measure it. Second, that we need to take into account is the wind data. What are the prevailing winds? So if there is no prevailing winds in that particular sample, or in Texas, in let's say in the summer, we don't have northerly winds, so we don't need to put a fence line on the south. The third consideration is where the community receptors. We talked before that most of the motivation for the fence line monitoring will be communities downwind of the facility, so we need to put our fence line. So as another things that we should know when we plan a system is that the gas plume is diluted with distance. If we want to have 2.4 ppb concentration of ethylene oxide on the fence line, it means that we got source that emits in concentration of 1,000 of ppm or sometimes percentage. If we don't need to measure in the facility ppb levels, because by the time it will reach to the fence line, it will be in a neglectable concentration. So if you want to do a combination of point monitor inside the facility and fence line, we don't need to take very expensive instrumentation inside and measure ppb levels, because ppb levels inside the facility are meaningless when we go to the fence line. So if you're talking about a duct that got 100% of ethylene oxide, by the time it will reach the fence line, we're going to talk about ppb levels. So what we should use, which instrument we should use for ethylene oxide monitoring. So we're talking about the open path, and it's the most suitable for the fence line because it's got ppb detection in it. It can cover a long way of measurement, and it's based on official US EPA method. We are hearing new technologies like the FTIR or category ring down, like the Picaro instrument that can measure, and yes, they can measure in sub ppb sometimes. But the bad thing about them, they are still very expensive, and they are point monitors, so you need to have tubing with them. And we talk about tubing with soluble compounds. It's not the best idea to have. The second option that I think that the regulator will go, like it went with the benzene rule, it will be either passive solvent tube or canisters, what they are doing today. But again, they will find it very hard to create a good analysis because of the solubility of the ethylene oxide. But beside that, the other problem is that it's time average method. So you will not have real-time results, and your result will average 2 weeks data. So you cannot tell where is the source. So it's a problem. For point monitor, we can either go with extractive FTIR, PTRMS, or instrument like Picaro, or we can use a cheap analyzer that costs $2,000 or a few $100, like a gas detector. It could be a PAD or electrochemical cells. And the main thing about them, they are very cheap. They are explosive proof easily, but they can measure in ppm levels. But as we saw before, ppm levels is okay results if we are talking about inside the industry. Again, I will emphasize that FTIR is an official method, like the canister, like the solvent tube. You got Tier 16 EPA method. If you don't like, you got the ASTM method, and you got the European method. And with official method of technology, you got an official quality assurance procedure, someone validated the technology, and there maybe you know how to do the detection limit. There is still debate about it, as you're going to see on next few slides. So instruments like the Picaro, they are recommended, but we should avoid tubing when soluble gas is present, like ethylene oxide. They are relatively expensive compared to the PIDs or the electrochemical cells. So if you don't need very low detection limit, there is no need to use those. It's not an official US EPA method. Just yesterday, I heard the EPA talking about it, and they expect it to be official maybe in the next 5 years. But if you're talking in the near future, it's a good technology. It works, but as an official method, we don't expect it to be in the next 5 years. Also, and if you look about the history, the open path technology was accepted as a method on, let's say, 1999, and now we start see people implement it. So that technology doesn't have any official method, so maybe in the next 10 years it will be mandatory by the regulator. So overall, we think it's an overkill when we are talking about concentration in the ppm range, then that is what we are want to measure our vents or something like that. We're talking about the point monitor. There are two options to go. If you're talking about total VOCs, we can go with a PID detector, and if we want to maybe specific to electrochemical cell, to a ETO, ethylene oxide, we're going to use electrochemical cell. They are suitable from 1 ppm, actually, to percentage, not from 100 ppm, and we can integrate it into our system. So let's say we took a PID. We don't know for sure it's an ethylene oxide, but now we got alerts from a cheap PID analyzer that says we got high VOC concentration. And then we're going to do the speciation with our open path FTIR. So we got an alert from the site that says we got high VOCs emission, and how we know it's an ethylene oxide. We look at the line near that gas detector, and now we can give you the composition of the VOCs over there. That's what we call the holistic solution. So these are the detectors, cheap detectors, 1,000 to a couple of $1,000 each, very cheap to install. And then we combine it with open path lines. So the point monitors are specific source detection. Most of our clients tell that the upsets, it's that one of the vents that's supposed to be closed, open all of a sudden, and they don't know it. So put a point monitor, cheap point monitor like that, in any one of your vents. It will be $1,000, $2,000 for each one of your vents. And then put in the surrounding open path FTIR, and that will give you specific compound identification, wide area, source location, etc. It will look something like that. So for conclusion, fence line measurement can be the nose for advanced warning if something goes wrong. We can put our system on the fence line. The moment something happened or something big enough happened to contribute to your fence line concentration, we will alert. We will alert. You will send your elder people to go and fix the problem. And the most critical number for your emission is how fast you find the problem. So if you find it faster, then you reduce your emission. Ethylene oxide can and should be monitored 24/7. The EPA said it, and I'm sure the industry know that most of the emission will come from offsets. So if we will not measure 24/7, we will miss those offsets. 24/7 real-time monitoring is the basic requirement to reduce risk and emissions. We're talking about threshold, but keep in mind, this is very dangerous compound and explosions. So if the motivation will be safety, it's okay. It's even better. And you got both of them in the same instrument. Using the D-fenceline system, this our D-fenceline system, we can guarantee below 1 PPB detection limit can be achieved on the fence line. Online quality assurance must be implemented. We talked before that maybe this data will need to be reported to the public or for the regulators, so you must be 100% sure that it's true. And I recommend spectral validation on real time. Source location will help you direct your elder people to fix the problem sooner. And we also, because we are measuring along lines and we got the wind data, we can also give you how much you emit. And sometimes facility over-reports their emissions. And we can conduct a test that will prove that maybe you emit less. Emitting less, ETO, it's very economical for the facility because now you can appeal for reducing elder project, and that will accumulate for a few $100,000 a year. This is a few of the fixed installation, deserts or near the shore. Atmosfir can help with the planning stage, execution of the program, and daily maintenance quality assurance, or we can just give you the software. We can do also short-term project. I recommend my client start with 4 months project, see the technology, feel it, find your problems, and then you can design a better system. So we can do a shorter project. We got 2 traders in the United States that are quite busy, but with enough time in advance, we can do a project like that. And we can do a flux estimation, like how much ethylene oxide I'm actually emitting from leaks and how much from source. We can do WISE LDAR that we're going to talk about later. That's mean finding the leak faster. We can do flare combustion efficiency, etc. So that's it. Short, and if you got a question, I will be happy to answer. Yeah.
So speaking of the flux estimates, how are you integrating in the measurements? Are you integrating it with the system, or are you responsible?
I know one official US EPA method that can measure fluxes. All the rest of them based on estimate. The method called OTM10, US EPA OTM10. And what we do, we shine a beam of infrared light if you're talking about ethylene oxide for different direction and different heights. Then we can multiply it by the wind vector, and we can actually give you how many grams per second you are emitting every second. So it's official method, the only official method that measure, not estimate flux. So we've got the concentration along lines, multiplied by the wind vector will give you gram per second.
Yeah, I guess that was
so each one of our system equipped with wind monitor. And because we got time resolution of 1 minute or 5 minutes, each measurement got concentration, average concentration with wind direction and wind speed. So it can be done, and we did quite a few of those, mainly in Canada.
I had the same question. We go back to your slide. How do you make that distinction?
Yeah.
Yeah.
And what we found out, most of the EPA regulation will tell you an EPA method you can use meteorological data up to 100 kilometers from the source. What we find out, and I think all of the service provider in California, that even in the same site, if you put 3 wind monitor, sometimes each one will show you a different wind vector. That's why we equipped each one of our instruments with its own meteorological data to be more precise onto the site. So wind monitor data, it's less than $2,000 US. So we decided if we are talking about $250,000 equipment, $2,000 should be implemented and to get you this data.
Why is LDAR a system that stays there forever and ever and ever, or it's set apart, does it allow you to now plan, what I'm taking?
Good question, and I don't want to oversell it. So first of all, our system can stand, and it can be FTIR or it can be tunable dyed laser. It depends. If you're talking about normal LDAR project, you don't need to go with the FTIR. If you got FTIR, use it. But if you're just looking about normal LDAR project, it doesn't distinguish between each one of the VOCs. So we can take a tunable dyed laser that can see all the VOCs and do the same procedure with that. So we will take down the cost. For your second question, and I think it's the most important one, we will not tell you what is the flange that is leaking. We cannot. But we can tell you, let's say, wide area 50 by 50 meters. So now you can take your elder people to the area that needs to be measured and just change the prioritize. So they're doing today routinely, you do today that area, tomorrow you're going to go to that area, that area, that area. But if you will combine it with our technology, I will tell you, I know that you need to do this area, but we've got problem over here. So take your elder people over there. And then what is the leaking flange? They will use either OGA cameras or sniffers. Okay. Yeah, we cannot tell you what is the exact problem, but today, if you are in the elder project, people talking about the S4, there's a lot of chain of PIDs detectors. So we can do a combination of open path and PIDs chip detectors inside. And with that, we can even drill down the resolution. Again, not to the exact flange, but then let's say about a few meters resolution. So then your elder people will have an easier job. Sorry?
What's the minimum VLC concentration?
Using our FTIR on the fence line, we are talking about 1 to 2 ppb on the fence line. And the regulation, I think in the United States, starts from 500 ppm on the valve. So it's suitable for this. By the time it will read the fence line, it will be in ppb levels. But combine that with a cheap PID or electrochemical cells, you will find the problem in that areas. Yeah.
Let's go back to y'all's question about the techniques vertical radial mapping. That's what OPM references. If you actually put the meteorological station at the two heights and use a combination of those wind speeds for the more accurate determination of where it's coming.
But I can tell there is the official method and the official configuration. From our experience, you will not find too much difference if you do the 5 lines or 2 different lines in the same height. In the 30% uncertainty, both with them will sit. So if you will go to fixed installation that represent fluxes, you don't necessarily need to put in each line 5 retroreflector in different. So 2 of those will be enough, and you will get a good enough data for that. Okay, better for us.